Okay, I said the other day that we were basically electrical beings, that the atoms that make up our body were really held together by electrical forces. And so the same force that holds a sock to your pants when you take it out of the dryer, that static cling, that's what literally holds us together. And I want to talk a little bit more about these electrical forces and how they hold atoms and molecules together. And to start with, we're gonna look at the two basic parts of the atom. We're not going to talk about neutrons. We don't really need to discuss that at this point. But it's the proton and the electron. Now the proton, of course, is positively charged, and the electron is negatively charged. And of course, opposites attract, and like charges repel. So if you have two protons next to each other, they will get repelled by each other. And likewise, if you had two electrons next to each other, they would get repelled by each other. But if you had a proton and electron next to each other, they would get attracted to each other. All right? Now, in an atom, this is basically what holds an atom together. So you've got a proton. Let's say we look at the simplest atom, which is hydrogen. So you've got a proton with an electron around it. And these are, in the hydrogen atom, these are held together in the atom. Now, typically in the younger grades and in the media and stuff, and on wherever you look at anything about atoms, you'll see this kind of thing with like a circle around it, right? And the electrons may be going around in a circle. Well, that's not really how it happens. You can think about it more. Think about it more like this: the electron is around the nucleus, but think about it more like a cloud. I think about it like a cloud of gnats, for example. But this cloud is just one electron that's just moving around, and we don't really know how it's moving around the atom. It's moving in kind of an unpredictable way around the atom. It's just there, this negative charge, okay, that's held to the atom. Now, different atoms, different kinds of atoms, have different numbers of electrons. And those electrons have different arrangements around the atom. The electrons are actually arranged in like concentric shells, as you've probably seen in different places. So these different atoms have different numbers of electrons that are arranged in shells around the atom. And these different arrangements cause the atom to behave differently. In particular, the different arrangements of electrons and the different numbers of protons in the nucleus and electrons around the nucleus make these atoms have different attractiveness or different attractions for electrons. So different atoms have different numbers of protons and electrons, and these electrons have different arrangements around the atoms. And the combination of different nuclear charge, the nucleus is where the protons are, so the positive charge in the nucleus, combination of different nuclear charge with the different arrangements of electrons leads to different behaviors. So different atoms and different elements behave differently. For example, And this is actually the most important example that we're going to talk about. For example, it leads to different electronegativities. Now, electronegativity means the attractiveness of the atom for electrons. And in general, if you look at the periodic table, which looks like this, it's got 2 columns here, then it's got 10 columns in the middle, and then it's got 6 columns over here. So we'll go 1, 2, 3. Let's add one more in there. If this is a periodic table, basically the attractiveness for electrons increases as you go up diagonally like that toward the right-hand corner. So increasing attractiveness. So the strength of attraction for electrons increases from left to right on the periodic table. Okay. Now, when 2 atoms meet, there are 3 possibilities. First, there may be no bond. Okay, so the atoms may not form a bond. They may not have any tendency to form a bond. This is when there's no attraction between them. And why would there be no attraction? There could be a couple of reasons for that. Primarily, we're talking about here, there's no attraction because all of the shells, all of the shells where the electrons are held, are filled. So basically there's no more room around that atom for more electrons, and so the atom's not going to attract other electrons, not going to have an attraction for other electrons because those shells are already filled. Okay. The second option here is called a covalent bond. So in this case they do bond together. It's called a covalent bond, and this is when they're going to end up sharing electrons. Now this is when they have a moderate attraction for each other. So each atom has about the same. Each atom has about the same attraction for electrons. Each atom has a similar attraction for electrons. Okay? So they end up in kind of a tug of war on the same electrons, and it typically, actually not typically, it's always a pair of electrons. They end up in a kind of tug of war over a pair of electrons, and actually one electron came from one atom, one electron is from one atom, and one is from the other, typically. Not always. But they're going to have this tug of war of a pair of electrons, and that is a covalent bond. So the covalent bond literally is nothing more than a pair of electrons that are being attracted by 2 different atoms. Alright? And that's what holds the atoms together. Now the third option is called an ionic bond. Now, an ionic bond occurs when we have the stealing of an electron. Okay, this occurs when one of the atoms is a lot stronger than the other, when it has a much greater attraction. One atom has a much greater attraction for electrons than the other. One atom has a much greater attraction for electrons than the other. Okay? It steals an electron, or more than one electron possibly, from the weaker atom, okay? Now it has an extra negative charge. And the other has a positive charge because it just lost one of its electrons. See, all atoms start out neutral, so now this one has lost one of its electrons. And the two atoms stick together because one is positive and one is negative. So that's the basic idea of ionic bonding. Okay, so in the covalent bond, we want to draw a picture of a covalent bond. We might draw something like this. Okay, two nuclei are attracted to the same electrons, and that makes a molecule. All right, in this case, maybe the hydrogen molecule, because it's got single, each one is just made of one proton. In an ionic bond, it's a little bit different. In this case, you end up with one atom that has a positive charge, we'll say sodium ion, and then one atom, say a chlorine atom, that develops a negative charge because it stole an electron from the sodium. And then what happens is the sodium is now positive and it sticks to the chloride, which is negative, and you get an ionic bond. And what happens with ionic compounds is that they don't form molecules, they form just crystals, right, where you have an alternating framework, alternating pattern of negative and positive ions. Okay? Now, with covalent bonding, covalent bonds, they form molecules. Okay? Covalent bonds form molecules. And different atoms form different numbers of bonds. Different elements. And an element is just a kind of atom. So you can think about an element as a kind of atom. Different atoms form different numbers of bonds. And it's based on how much room they have in their shells. All right? Carbon has room for forming 4 bonds. All right? Nitrogen and phosphorus, they have room for forming 3 bonds. Oxygen and sulfur, they have room for forming 2 bonds. And hydrogen has room for forming only 1 bond. And this is why we hear that carbon forms 4 bonds and nitrogen and phosphorus form 3 and oxygen and sulfur form 2 and so on. And if you've ever built molecular models with those little kits, that's basically what's going on there. But in every case, they're just electrons being shared between these atoms, and they all have tendencies to share different numbers, and this is what results in the different shapes of molecules it can form. And by the way, I brought out these 6 elements because they're the most common in our bodies and in biological molecules, and the molecules we're going to be talking about soon in this class.